So today we are going to learn and understand the concept of electricity. There are three main branches in electricity or terms used in electricity. They are just voltage, current, and resistance. Now when we talk about voltage, it is the force which pushes current in a conductor. Another name for voltage is potential difference. Now when we talk about voltage, the best example to use is the water system, the pipes. Now let's say you have a water system. The force pushing the water through the entire house is, it can be a pump or as a result of gravity, where your poly tank is at the top of your house, or when the poly tank is at the down, so you need a pump to push the water to the top of the house or in all parts of the house. Now when we talk about current, current is the electrons moving per second. So the rate at which electrons move in a conductor is what we call current. Something we can associate with current is the same as the water system. Now the current will be the water in the pipe, and the conductor will be the pipe itself, the PVC pipe. And resistance. For resistance is the opposition offered to a current in an electrical system. So sometimes you are supposed to get 240 volts, but instead of getting that, you get less, say roughly 220 volts, or your current gets reduced. So your resistance can change your current and your voltage. So sometimes in the water system, we have something we call a reducer, which changes your water pipe from maybe a half inch into a 3/4, or even 1 inch to 3/4. It just reduces the amount you get. That's a resistor. Now the component resistor is this. The resistor has a color code. That's how we can tell the value of each resistor. Okay, so depending on the color, then we get the resistance. We have types of resistance. We have ceramic resistance, we have variable resistance, also known as rheostat, then potentiometer. That's what they usually use and in regulators, and majority of the time that's what they use in regulators or devices which need to change their value for resistance. Okay, so now let's get the concept of parallel and series connection. When we talk about parallel connection, it means connecting the positive terminal to the positive terminal of another component, and connecting the negative to the negative of another component. That's entirely the concept of parallel connection. Now in parallel connection, your voltage remains the same, but your current changes. So if you have two batteries, let me pick these two batteries. If I should pick a 1.5 AA battery and connect the positive to this positive. Okay, I'm going to change the wire to the normal wire. So I connect the positive to the positive of the side. I make it straight enough, and I connect the negative to the negative of the side. I change the color to red. That's the color associated with positive, and then negative I change to black. Now if I should connect this to a multimeter and read, the voltage for this will be 1.5, but the current is what's going to change. So let's get a multimeter and check if what I'm saying is correct. So I get a multimeter, and the positive I connect to the positive terminal of one, and the negative I connect to this negative, and I run the simulation to see if what I'm saying is true. So I get 1.5 volts. So that's parallel. Now for the current, it's going to change. I get 6.00 amperes. Now the unit used for current is ampere, and the instrument is ammeter. And for voltage, the unit is volts and the instrument is voltmeter. Now this means that since we are getting 6 ampere, it means that one battery gives a current of 3 volts. No, sorry, 3 amperes. So I'm just going to remove one battery and see if what I'm saying is correct. So I now connect this to this and change to red, and I run the simulation. I get 3 amperes. So it means that in parallel connections, the current add up, but the voltage remains the same. That's for parallel. Now let's take series. So I bring this same battery, the 1.5 volts, and we are going to do the series connection. So in series, the voltage add up and the current remain the same. So I'm going to connect, in series we connect the positive to the negative. So this positive connects to the negative. So I can make this color any color of my choice, because it doesn't really have any terminal or polarity. So I can now connect this negative to the negative and change this to black, and connect this positive to this positive, red. Now if I should run the simulation, the current, since the series, I'll get a current of 3 amperes, and the voltage, I'll get a voltage of 3 volts. So let's run this. So as I said, 3 amperes, and the voltage will be what? 3 volts. So that's all for parallel and series connection. Now this is for active components. When we say active component, they are components which produces electrons or current, or they store energy to be used. Okay, that's for active component. Now let's go to passive component. So when we say passive component, they are the components that use energy. For example, LEDs. Now LEDs, we can connect them in parallel connection and series. For example, this, the LED, the anode means positive and the cathode means negative. So if we should connect this cathode is negative. So if we should connect the cathode to the cathode of the next LED, then we change to black. We have this as negative, and we should connect this and we change to red. So these are positive. So now we have connected this in parallel connection. The cathode connected to the cathode of the next component, and the anode connected to the anode of the next component. That's parallel. For this one, since we cannot produce power, the passive component, they take in power, so we can't measure their volt and their the current. It is only when we connect them to a source of power we can know their closed circuit voltage and current. And for the series connection, it's quite simple. It's the same as the active. Connect the anode. We connect the anode to the cathode of the next component, and we change this to maybe gray again, since it doesn't have any uh, association. It's just the positive connected to the negative, so we cannot give it a definite color. But the cathode, this one, we can give it a definite color because it's negative. It's negative, so we can give it. So this is cathode and this anode. You can connect any source of power. So let's bring this battery and let's rotate it. So since this cathode, you have to connect the cathode this way, negative, and change to black, and we can connect the anode, the positive, change it to red. Now every LED has the maximum or the drop down voltage. For red, they have the least among all LED, which is 1.2 volts, and I think the highest would be violet and followed by blue. So since this is 9 volts and this 1.2 connected to this 1.2 is quite since this is series connection, we get roughly 2.4, which is far lower than 9V. So we are going to change the color to blue so that we don't blow our LED up. So we can run the simulation and it's turned on. Now see what they are telling us. Current through the LED is 91.0 milliamperes, while recommended maximum is 20 milliamperes. The usable lifetime of the LED may be reduced. It means that if you connect a large amount of current or voltage to something which needs a small amount, it's going to reduce the span or the lifetime. So to do that, we usually use a resistor to reduce the current. So we are going to move this and connect this to this part. Now resistors do not have a specific terminal, okay? They are unpolarized, they don't have any polarity. And I run this simulation. Okay, now you see it's dim. It's not as very bright as the previous one. So it means you have to change the value of our resistance. So this is 1 kilo ohms. Okay, resistance is measured in ohms. So I'm going to change this to 220 220 ohms and run the simulation. Now it's bright like before, and we don't have any warning. Okay, so thank you for watching. See you next time.